Imagine a star so huge, its surface would stretch far beyond the orbit of Mars, swallowing planets and even the asteroid belt. This is Scuti, a red supergiant or hypergiant, and one of the largest stars ever found, sitting 5,900 light-years away in the constellation Scutum. Scuti first appeared in star catalogs back in 1860, but it wasn't until astronomers noticed its changing brightness that it stood out. It's a pulsating variable star, meaning it rhythmically expands and contracts with a cycle of about 740 Earth days. At its widest, recent research estimates Scuti's radius at about 909 times our Sun, over 600 million kilometers, or 4.23 times the distance from the Sun to Earth. Some older studies guessed an even larger size, up to 1,700 times the Sun's radius, but those huge estimates are now in doubt. Placing Scuti where our Sun is, its outer layers would engulf the orbits of Mercury, Venus, Earth, and Mars, and might even stretch into the asteroid belt. Though gigantic and luminous, Scuti is too faint to see with the naked eye. You'd need binoculars or a small telescope just to glimpse it. It's surrounded by thick, dusty clouds, shedding mass at a rapid pace, over tens of thousands of times what our Sun loses each year. Scuti's surface temperature is around 3,550 Kelvin, much cooler than our Sun, giving it that deep, distinct red color. Its mass is uncertain, but most estimates put it at 7 to 10 times the Sun's mass. Some sources once claimed up to 30 times more. The sheer size of Scuti stuns astronomers. Its volume could fit about 750 million suns, or in some rough estimates up to 5 billion. Scuti sits near the crowded galactic center, deep in what astronomers call the zone of avoidance because of thick dust blocking our view. Astronomers measured its vast size using observatories like the Very Large Telescope in Chile and special techniques called interferometry. But measuring a star this big is tricky. The distance, and therefore the size, of Scuti is still debated, with modern methods suggesting more modest numbers than older claims. Scuti is a semi-regular variable, changing its brightness with a rhythm of roughly 740 days as its outer layers pulse in and out. It exhibits emission lines and is a weak maser source for molecules like water and silicon monoxide, evidence of its wild, unstable outer atmosphere. Scuti doesn't have a known companion star, unlike some hypergiants, letting scientists focus just on its own evolution. The star has progressed beyond fusing hydrogen in its core. Now it's turning helium into heavier elements, signaling the late stages of stellar life. Because of its metal-rich composition and huge mass, Scuti is expected to end in a spectacular supernova explosion. Some models predict Scuti will transform into a yellow hypergiant or luminous blue variable before its explosive finale. When its iron core forms, gravity will overwhelm outward pressure, collapsing the core and detonating the outer layers in a final, brilliant blast. Scuti isn't alone among stellar giants. Stars like VI Canis Majoris and NML Cygni may rival or even exceed its size, depending on survey methods. Despite decades of study, the single biggest fact about Scuti is that its true size is still debated, highlighting the challenges in studying extreme stars. Why does it matter? Studying titanic stars like Scuti helps astronomers explore the ultimate fate of massive stars and the origins of cosmic elements. The most awe-inspiring number, Scuti's outer shell would fit hundreds of millions, possibly up to billions of suns inside. By tracking how Scuti changes and sheds mass, scientists get a glimpse into how giant stars live and ultimately die across the galaxy. And when Scuti finally detonates as a supernova, it will briefly outshine entire galaxies and enrich space with heavy elements for new stars and planets. Our telescopes may capture only a fuzzy speck, but Scuti's story stretches across time and space, reminding us how much we still have to learn about our universe. As astronomers improve their tools and techniques, maybe one day we'll finally pin down the true scale and ultimate fate of the universe's most massive stars. That's your Cosmic Bite for today. Tap subscribe. I've got a fresh space fact for you every single day.